Day 23 of cracking 500 AI and data science interview questions challenge. 5 questions a day, 100 days. If you are new here, don't forget to check out the playlist. You might have missed some key questions that will be important in cracking your next interview. What is the difference between accuracy and F1 score? Accuracy looks good on paper until your data becomes unfair. Accuracy simply measures how many predictions the model got right. For example, if your model predicts correctly 90 out of 100 times, accuracy is 90%. But this number doesn't tell the full story, especially in imbalanced data sets. Imagine a medical test for a rare disease affecting only 1 in 100 people. If your model predicts no disease for everyone, accuracy is 99%, but it missed the one patient who actually had it. That is why we use F1 score, which balances precision and recall. It focuses more on how well the model identifies the minority class, the important or rare cases. So, in short, accuracy predicts how often it is right. F1 score tells all about how fair and reliable it is, especially when data is imbalanced.
What are precision and recall in simple terms? Think of precision as how careful your model is, and recall as how alert it is. Precision tells us when the model predicts something positive, how often is it correct. Out of 100 predictive frauds, if 90 were truly fraud, the precision rate here is 90%. High precision means fewer false alarms. Recall tells us out of all real positives, how many did the model actually find? Out of 120 real fraud cases, if 90 were detected, the recall rate here is 75%. High recall means the model catches most positives even if it sometimes raises false alarms. Choosing between precision and recall depends on context. So here for example, fraud detection values recall, catches all frauds, while spam filters value precision. It don't block real emails. What is a confusion matrix? A confusion matrix is your model's report card. It shows where it shines and where it struggles. Here, the confusion matrix is a 2 by 2 table that compares actual versus predicted labels. Look at this table carefully. True positive says all about model correctly predicts positive. False positive is something model predicts positive but it's actually negative. False negative misses a real positive case. That's where model has some default errors. True negative means model correctly predicts negative values. What is ROC curve and AUC in machine learning? Imagine testing your model under every possible condition. That is what ROC does. The ROC curve receiver operating characteristic shows the trade-off between true positive rate, the recall value, and false positive rate across various thresholds. Each point represents a different decision boundary of the model. Here, true positive rate TPR actually denotes how many actual positives we correctly got, and false positive rate explains how often we incorrectly flag negatives as positives. The AUC, area under curve, measures how well the model separates classes. If AUC is 1, the model is perfect. If AUC value is zero point 0.5, it is guessing in a random way. It is great when you want to compare multiple models objectively. The one with the higher AUC usually performs better overall. Why do we use cross validation? Training once can mislead you. Cross validation makes your results trustworthy. When you split data into train and test, results depend on that split. But what if you got lucky with one random test set? Cross validation solves this by splitting data into multiple parts called folds. The model trains on some folds and tests on others, rotating through all. In five-fold CV, it trains on 4 parts, tests on one, repeats 5 times, and averages results. This ensures a model's performance is consistent and not dependent on one random sample. It also helps detect overfitting early. Here is your day 23 dose of insight. If you want to stand out in an interview, don't just quote metrics, explain why you choose them. Say something like, I use accuracy when classes are balanced, F1 score when they are not, and ROC-AUC to compare models. I also validate results with cross validation to ensure consistency. This shows how you think like a real data scientist, not just someone who memorizes formulas.